In the vast, unimaginable universe, where the stars shine like ancient flames and the galaxies in the cosmic dance, there is a mystery. It has been in human memory since the dawn of time: the origin of the world. For centuries, the human mind has struggled with questions that defy simple answers. What happened before the universe? Is there a time before the same time? If there was no before, what ignited the cosmic flame that produced everything we see around us? These questions are fascinating and cannot reach the edge of human understanding and approach the depth of knowledge. In a world that is supposed to be infinite and infinite, the idea of a real beginning seems strange. Yet this disruption has led to some of the most profound scientific research in history. The trick that catches the imagination is that the popular Big Bang Theory, long thought to be the ultimate explanation for our origins, may not be the end of the story. What if there was something before the Big Bang? What if the world as we know it is just one chapter in a larger and more complex world saga? This disturbing phenomenon isn't just science fiction. It's based on advanced theoretical physics. And it's an opportunity that has the potential to change our understanding of life itself. For most of human history, the question of the origin of the universe was answered by an eternal God, an eternal being who controlled everything. There are many versions of this view. Even famous scientists like Isaac Newton believe that God created the universe some 6,000 years ago. This belief in divine creation is not only a religious doctrine, but the framework in ancient science. The universe was believed to be stable and unchanging, with the stars and planets moving in predictable patterns determined by a higher power. However, this comforting idea of a permanent and eternal world began to come under the weight of new discoveries. When Albert Einstein came on the scene, many scientists believed that the universe was eternal, without a beginning and an end. Stars may be born, die, nations rise and fall, but the whole universe will remain the same on the largest scales, forever more than the equilibrium of the universe. The 20th century brought about a seismic shift in our understanding of the world. In the 1930s, observations by astronomers such as Edwin Hubble provided conclusive evidence that the universe was expanding. This discovery is revolutionary and challenges the foundations of the eternal and revolutionary world that have been accepted for centuries. We know that the stars are receding from the beginning of the universe, a time when everything we see today was in a small, hot, and dense form. This is the birth of the Big Bang Theory, which states that the universe began as a singularity, a region of infinite density and heat, from which space and time emerged. The discovery of the microwave background in the 1960s solidified the Big Bang as the primary explanation for the origin of the universe. This tiny glow entered the universe as a hot remnant from the first universe, a snapshot of the universe only 380,000 years ago. As the Big Bang Theory gains more traction, it also raises deeper questions that have yet to be fully answered. The most important of these is what happened before the Big Break. If the world came out of singularity, why did this event happen? And if there is no before, according to some theories, how does this fit into our understanding of cause and effect, which is a fundamental principle of the natural world? Enter Brian Cox, a physicist whose work has rekindled interest in these age-old questions. In a remarkable revelation, Cox suggested that the universe predated the Big Bang and questioned the idea of the Big Bang as a final beginning. According to Cox, what has long been thought about the birth of the world is just one event in a larger, more complex history. Brian Cox's idea that the universe existed before the Big Bang is not just a provocative idea. It challenges the foundations of modern civilization. If the Big Bang wasn't the beginning, what was? Was there ever a time when the world lived in a different state, governed by different physical laws? And if so, what does this mean for our understanding of space, time, and the nature of reality? These questions take us into the unknown, where the boundaries of science are blurred by philosophy and imagination. But they open up exciting new ways of understanding the world. Cox's work, along with that of other physicists, suggests that the Big Bang was not only the beginning of everything, but also the beginning of everything we know. This simple but profound difference has huge implications for our understanding of the world. One of the most important developments in modern cosmology is the theory of cosmic expansion, which states that the universe expanded rapidly in the first fraction of a second after the Big Bang. This period of expansion explains many of the observed features of the universe, such as the mass balance and distribution of galaxies. But the rise raises new questions. Why did it grow so fast? What was the world like before the rise? According to the inflation model, the universe was filled with an energetic field that expanded rapidly. At the end of the rise, this energy became the matter and radiation that makes up the universe today. However, it raises the intriguing possibility that the world could exist in a different way before the rise, one that holds the key to understanding reality of the world. The discovery of the cosmic microwave background, CMB, was a milestone in the history of the universe. This small amount of radiation, first discovered by Arno Penzias and Robert Wilson in 1964, is strong evidence for the Big Bang theory. The CMB is the early universe, a sign of a time when the universe was hot, dense, and filled with a plasma of particles. As the universe expanded and cooled, this plasma mixed with neutral atoms, allowing light to freely travel through space for the first time. The CMB is not consistent. The changes in temperature correspond to changes in the density of the early universe. These variations eventually lead to the formation of galaxies and other large structures in the universe. Studying the CMB has allowed scientists to learn a great deal about the early universe, but it has also revealed some puzzling anomalies that challenge our understanding of cosmology. One of the most significant challenges to the Big Bang theory is the concept of the singularity, a point of infinite density and temperature where the laws of physics as we know them break down. The idea of a singularity suggests that the universe began in a state that defies all known physical laws, raising the question of whether our current theories are sufficient to describe the origin of the universe. Some physicists argue that the singularity is a sign that our understanding of the universe is incomplete. They suggest that new physics, possibly involving quantum gravity or string theory, is needed to fully understand the earliest moments of the cosmos. This has given rise to different models, such as the Big Leap theory, which states that the world will go through cycles of expansion and contraction, with each bang followed by a big crisis, and then big contraction. The Big Bang. The Big Leap theory is one of the most attractive alternatives to the traditional Big Bang model. According to this theory, the world has no beginning and no end. Instead, it goes through cycles of expansion, and each cycle begins with a Big Bang, followed by a period of expansion, and finally ends with a big contraction. The world turns into a huge state and starts a new cycle. The Great Leap Project. It has many beautiful features. The singularity problem is avoided by saying that the universe never reaches a state of infinite density. Instead, the universe shrinks as it approaches a minimum size and returns to a new phase of expansion. This change pattern may also explain some of the observed variations in the microwave background, which are remnants of past changes. Another key development in the modern world was the emergence of string theory, a theoretical framework that attempted to unify all the fundamental forces of nature, including energy, into a balance theory. String theory states that the building blocks of the universe are not particles, but small, vibrating strings of energy. These fields can exist in many dimensions, leading to the appearance of a multiverse, a large collection of worlds, each with its own physical laws and locations. The idea of a multiverse has great implications for our understanding of the world. If our universe is just one of many universes, the Big Bang may not have a specific event, but one of many big impacts in different parts of the universe. It raises the idea that different regions of the world have different physical laws and so on.